So today we have Leetcode Weekly contest. So it's just 50-second remain to start. So let's wait for the contest. It's just 30 seconds to start. So let's wait for the contest to start. It got started. We are going to record. I am going to record myself. And try to explain my thought process also. I will try. As much as I can. So the contest has been started. These are the problem statement we have. First, second, third, fourth. Okay. So the first question is you are given a zero indexed integer array nums and an integer threshold. Okay. Find the length of the longest subarray of nums starting at index 1 and ending at index L and ending at index R that satisfy the following condition. Num L modulo 2 is equal to 0 for all indices I in the range L to R minus 1. Num modulo 2 is not equal to num I plus 1 modulo 2 for all indices of I in the range LR. Nums I is less than equal to threshold and the length is less than 100. So we can iterate over all pair of L comma R and check the condition is satisfied or not. So we can write a solution of order of n because the length is 100. Array length is 100. So I will start a loop for L. L can vary from less than nums dot size L plus plus and so on. For the R we can write int R equal to 0, R equal to L, R less than nums dot size R plus plus, and in this range we have a loop int k equal to L, k less than equal to R and k plus plus. Now we have two conditions to check. Three conditions should be satisfied for that sub array. First condition is okay. The first condition is this num I. Okay. So first condition we have three cases now. Bool 1 first condition के लिए bool 1 that is initially true, let's say. For second condition we have a bool variable of name bool 2 and its initial value is, let's say, true. And the third condition is we have, for that I have a bool variable whose name is 3 and its value is initialized with true. These are the cases we have. Now what we can do, if nums k threshold means is less than equal to num. If nums k is greater than threshold, it simply means your third condition get false. So 3 and equal to false. Do it. Your third condition got failed. Now what is your, if I plus 1 is less than equal to r, then check if nums I modulo 2 is not equal to, is equal to modulo 2 is equal to nums I plus 1 modulo 2. So if the remainder of ith element and I plus 1th element is same when divided by 2, your second condition got false na, your second condition get failed. So for that what you can do, okay, so for that you have your second condition got false, fulfilled. That's why you will write here 2 and equal to false. And what's about the first condition? The first condition is simple, if nums L modulo 2 is not equal to 0, then first condition got false. 1 and equal to false. So after having this for loop, you have the condition now. You have 1, 2, 3. If all is true, that means 1 and 2 and 3. These three condition is true. That simply means this length can maximize your answer. So what is this length of this array? So let's say initially you have a subarray of length answer, you have stored that answer can be the value, but now you have another subarray which is satisfying the condition. So you have to write here that if this length is greater than the previous stored length in answer, then answer must be updated now. So the current length of this satisfying subarray is r minus l plus 1 simply. So write it, and after that what we can do, we can simply return answer. So here in answer equal to 0 initially we have. So this is the code we have. Let's say it should work. So greater than threshold. So we have a incorrect spelling of threshold. What is the I plus 1? Not I plus 1, it's L plus 1. No, it's K. Here we have K now. K and K plus 1. And here K plus 1. These are the things we have. What is this? What is this? We have to call maximum now. Function name max. So these are the little bit of errors we have. Now it is getting 3. So we are getting our expected answer. So 313. It's correct. So we can submit it. So by looking at the constraint, we have written a solution of order of NQ. So the next question is prime pairs with target sum. You are given an integer n, and we say that two integer x and y form a prime number pair if you have given an integer n, and we say that two integer x and y form a prime number pair if x and y is between 1 and n, and y is greater than x or equal to x. X plus y is equal to n, and x and y are prime numbers. So you are given a 2D sorted list of prime number pairs xi comma yi. The list should be sorted in increasing order of xi. So if there are no prime numbers at all, return an empty array. a prime number is the list should be returned a 2D sorted list of prime number pairs xi comma yi. Okay, so you have given an integer n and they are expecting from you that you will return an array which is sorted according which will contain a pair of xi comma yi such that xi and yi is between 1 and n, and x plus y is equal to n, and x and y are prime numbers. So that's what they are expecting from you. It's actually that. So how can we do that? So n can be less than equal to 10 to the power 6. So we want to find all the prime numbers in 1 to 10 to the power 6. So we can basically I have a function. Previously I have stored some function for calculation of prime number. So I am not going to code for finding prime number. I will simply use that code. This is the white is prime. Control plus C. Take it. This is the function I have. So I am just copying this function here. Okay, bool is prime. So I will just make a bool type of array is prime whose size is let's say I have to calculate all the numbers from 1 to 10 to the power 6 that it is prime or not. So I will 2, 3, 4, 5, 6. That's it we have. So let's count it 1, 2, 3, 4, 5, 6. So 10 to the power 6 plus 1 side, and I will just simply call this prime function and I will give it is prime. Name it as prime, a small letter. Okay, so after running the whole function we have a boolean array, and ith index of boolean array stores true. That means ith element is prime, otherwise it is not prime. Okay, so that's it. So now what we can do, let's run a loop. Let's run a loop. Let's run a loop. And before running the loop, let's make another vector of int visited, though. So let's call it though. Just make it n plus 1 now. Just make it n plus 1 comma 0. Here we have another argument, let's say int n. So just make it less than equal to n and do it. Here make a little change. Okay. Is prime. So that's it. That's the change we have. Here also we have to make it n. Here also we have to make n. Okay, that's it we have. So after this change we have a for int I equal to 0, I less than n, I plus plus. That's it we have. So we have a number at this time if So let's write a condition uh, if this number I is prime, so that means is prime of I is true, has to be true, has to be true. That's it. We have from 1 to n, I equal to 1 to n. So if it is prime, so let's call it is prime of I is true. That's it. And also if is not visited of I, if I is not visited, that means I is not used, then only we can use it, do it. And check if is prime n minus n minus n minus is prime n minus I. If both is prime and is not visited I, that means simply answer dot pv, answer dot pushback. So this is the x comma y we are expecting. So this x comma y is the possible answer. So I am just simply pushing in my answer vector. So we have a vector of int. I have made its name is answer for storing the answer value. So after doing this, we can just visited of I equal to 1 and visited of n minus I is equal to 1. So that's it, what we can do. I and n minus I. Okay. And after all these things, we can just return answer. That's it, what we can do. That is the simple thing we should do. Let's check it will work or not. So we have to pass two argument. One is, another is n. 3755. So it's working now. You can see it's working. So that's the approach we have. I have just do one thing. I have calculated all the prime numbers in range from 1 to n, and after that I have simply what I have done, I have iterated over all the prime numbers and I checked if it is prime, then n minus I should also be prime, and if I checked I is prime and n minus I is also prime and n minus I is not before used, then that means we can have we have got a pair I comma n minus I, which is whose sum is n, and I and n minus I both are prime. So that's it we have. So we can submit it. It should work. So it's accepted. So let's move to the third question we have. You are given a zero index integer array nums. A sub-array nums is called continuous if I plus 1, j be the indices in the sub-array. Then for each pair of indices I is less than equal to 2. So that's it we have. Okay. So return the number of continuous sub-array. Okay. So any sub-array in which the difference between maximum and minimum element in that sub-array is less than equal to 2, that sub-array we can call is continuous. So we have to count the number of continuous sub-array. Okay. Number of continuous sub-array. Okay, so how we can do this question? It's simple, just simple. We have array, we can store the prefix maximum of this array. That means if if we talk about a same array whose name is pref max, let's say I'm coding and along with I'm explaining. Okay. Let's say the size of array we have given is n, that is nums dot size. That's simple. Now I am making a vector of int pref max. I am naming this vector pref max and its size is same as the size of nums. Then what we can do, if someone tell me that what is the maximum value of element present in the nums from a starting to a starting index, from first index to first index. It's simple. The value present at the first index. So the pref max of 0 will be nums of 0. So pref max, what pref max is going to store? Pref max is just going to store the maximum value. Pref max of I stores the maximum value of element present in the range from 0 to 0 to 0 to I index in nums. So for that we can run a loop for int I equal to 1, I less than n and I plus plus. We can simply run a loop and we can write pref max of I equal to maximum of pref max of I minus 1, because the maximum value present at I minus 1 present from 0 to I minus 1 in nums is stored in pref max of I minus 1, and the ith element is nums I. So that's it, how we can calculate this pref max array. Then we want to calculate the number of subarray. Long answer. I have a variable answer variable of long type in which I am going to store the maximum value of number of subarray, which is continuous. And the continuous subarray means all the elements, any pair of element in that subarray have difference, have absolute difference. Mm, have absolute difference. No, what we can't do like that. We can't do like that. We have to write a solution of order of n. In order of n, we have to calculate this number of subarray which is continuous. And the continuous means all the element in the subarray, maximum and minimum element in this subarray having absolute difference less than equal to 2. If we start from 5, I can allow all the integer in the range. In the range 5 minus 2 to 5 plus 2. That's it. What we can allow. Okay. We can write a solution like sliding window, that we will increase the size of subarray whenever all the element differences. When we got an element which is not satisfying the condition, then we are going to decrease the size of subarray. Okay. That's it we have. So we can write a solution of sliding window here. We can write a solution of sliding window. So let's say initially your sliding window size is 1. That means your start is 0 and end is 0. So the first element in your window. Now what you can do? So let's write a solution while 1. Have a look. So let's do think and well. You have this window. In this window, you can store the maximum element and the minimum element in this window. So how can you do that? Okay, we can use segment tree for doing that. What is the maximum element and minimum element in this window? For that, we can use segment tree, maximum segment tree, minimum segment tree, for and we can have query in that segment tree. So just call this segment tree code for we can't code it very lengthy. We can have some code from anywhere, we can get it. Segment tree, minimum code. So we will do that. First, write the solution. So we have a query max. Let's say we have a max value, mx value. We can get this value from a query max. Let's say we have a segment tree in which we can query for the maximum in the range, something like that. So we can query that. So st comma en is our query. In the same way, we have another query, mn value, that the minimum value in this range from st to en. We can also query that from minimum segment tree query max st comma en. So we have these two query. After these two query, we have the maximum value in the range and the minimum value in the range. Okay. So what can be the case? If absolute value of so we have two cases. If en plus 1 is less than n, and we have another cases, en plus 1 is not less than n. Okay, en plus 1 is less than n. We have this case. It's simple. En plus 1 is less than n. We have en plus 1 is less than n. So that means we can increase the size of, and in the else case, if let's say we have, so that's it. So in this case, we can increase the size and also decrease the size. So if abs of mx value minus nums en plus 1 is less than equal to 2, and absolute value of mn value minus nums en plus 1 is less than equal to 2. If these two conditions get satisfied, that means this nums value present at this en plus 1 index can be the part of your window. So if it is part of your window, what we can do? We can simply increase this window size by increasing en value. Otherwise, if this is not the case, then we have to decrease the size of window, and which we can do by increasing the value of st. Okay. So if you are increasing the value of st, at the same time you should update your answer. Your answer is basically the number of subarray which are starting from index st. It's basically answer equal to en minus st plus 1. This is the number of subarray which is starting from index st and going up to en. So this is the condition we have. That's it we have. Okay. In the upper case, it's simply en plus plus. Okay, no, don't worry. But what about this else case? So en plus 1 is less than n. This is the first case, and the another case is en plus 1 is not less than n. En plus 1 is equal to n. This is the else case. In that case, we can simply do one thing. That let's say we have a n plus n into n plus. That means you have a array of length n, and you can have any two pair of indices can be the contiguous subarray. Then count the number of total contiguous subarray. It's just simply summation of 1 plus 2 plus 3 plus 4 plus so like up to n. So it is n into n plus 1 by 2. So we have a long variable value whose value is the length, and the length is en minus st plus 1. This is the subarray whose any two pair is valid answer. So how you can do that? It's basically answer plus equal to val into val plus 1 by 2. This is the case we have. So after applying all these cases, we can finally break. So our answer will store the required answer. So answer equal to return answer. Here also we can multiply it by 1 ln. So that's it we have. Now the problem is we have to apply range minimum and range maximum query. Range minimum query. So this is the code for the range minimum query. We will use this code. Okay. So we have the segment tree with simple range minimum query. So this is the okay. So we can use this code get mid. Okay. Okay. These are the codes we have. QSQE. What is this? Construct segment tree. So let's write the code by myself. So I am going to implement by myself because it seems that. So you have a segment tree of 2. You want to build 2 segment tree, one for maximum and another for minimum. Okay, that's it we have. So first is okay. Okay. So just make array int mx arr, mx arr, its size is 4 into n, and another is mn arr, its size is also 4 into n. So these are the two. Now let's call a construct function. Construct function. It will construct segment tree. So basically, give him an index that you want to build from 0 to n minus 1, and you have the original array nums, and you are going to store the result in mxarr, comma mn arr. So that's what I'm going to do. So it will construct. Then after constructing, we have just a simple query. So query also we can do now. We can also do query in the same query function can get me the value for both of these. So let's call it query, and we have to find in, let's say you are going to store all these value at index 1 of this segment tree. So the query will take that at first index the maximum and minimum value is present for whole range 0 to n minus 1, and you have and this value is stored in mx value array and mn value array, and also you want to find in the ranges from st to en, and you want to store the maximum value in mx arr. These are the array we have. So in this array the whole every ranges has stored. So you can go you want to store the maximum value in mx val, and you want to store the minimum value in mn val. So that's it we have. So how we can implement the things. So now let's call a void construct function. Let's give him a index ind. At index ind you are going to store the ranges from int s to e, all maximum value of these ranges s to e at index ind, and minimum value of also this range at index ind in another array. So the first array is your first array is int st, your mx arr, your mx arr, and your another array is mn arr. So that's what you have. Now you will have a mid value s plus e minus s by 2, and you will call the same segment tree to construct and store at 2 into ind index for the ranges from s to mid, and let's have a mx arr array and mn arr array to store the value, and you can call the same construct. Also you have a vector of int nums. So that's it you have. So you have another one argument nums which we are forgetting, and store the same for the other half part at index 2 into ind plus 1, and you have a bit plus 1 comma nums comma mx arr comma mn arr. So that's what we have. Now after running these two things, what will be the answer of this mx arr ind? equal to maximum of mx arr 2 into ind comma mx arr 2 into ind plus 1. That's it. That's what we have. And the same for mn arr ind equal to minimum of mn arr 2 into ind comma mn arr 2 into ind plus 1. So that's what we have. But we have one more case, that is if s is equal to e, that means simple mx arr ind equal to nums s and mn arr ind equal to, it's just simple nums e. That's what we have, and we can return from there. Okay, how we can implement this ratio and minimum. So have I called it the structure function? I have called rightly 0 to n minus 1. Okay, now we have the query. So what is the format of query? We have a int int, we have a int s comma int e. Okay, we have int we have a int mx arr array, we have a int mn arr array. ठीक है, mx arr array, mn arr array. Then we have a query start and we have a query int. Okay, query start, query int. Okay. Okay. That's it. We have query start, query int, and we have two more variable, int mx value to store maximum in the range, and int and mn value to store the minimum in this range. And I am making it a void type. Okay, simple. So int mid equal to s plus e minus s by 2. Okay. So query, we can call the same query for 2 into ind int s comma int e stm. So 2 into ind s comma mid comma mx arr comma mn arr comma qs comma qe comma mx val comma mn val. These are the things we have. We can call the same query. Okay, 2 into ind plus 1 comma mid plus 1 comma e comma mx arr comma mn arr comma qs comma qe comma mx val comma mn val. That's it, we have. Okay, here also we have, is there anything incorrect we have done here? Amend plus 1. Here one thing we have done incorrect, that is this. Oh, what we can have next? If e is less than qs, or one more case is, if e is less than qs, yeah, uh, q is qe is less than s. That means the range s to e doesn't fit the range qs to qe, is not the part of the range qs and qe. It's completely outside. That means simply return, if e is less than equal to qe and s is greater than equal to qs, that means the range s2 is completely lie inside the range qs and qe. In this case, mx value equal to maximum of mx value comma mx arr ind, and the same thing goes for mn arr. Okay, and the same thing goes for mn value equal to minimum of mn value comma mn arr, and value presented in the array mn arr at index ind. So this is the case we have, and from after writing it we can return from there. Okay, and if it is partial, we can go for the lower region. So this is the query system we are thinking of. So after writing whole code, I am expecting that it will run correctly. But let's see what happens. Time limit exceeded. So it's giving time limit exceeded. So let's comment out all this code. Let's find where is the problem in the code. Okay, so it's working. So if I will comment out this line and assign it a value 0 and assign it a value 0, then it should work. It will give TLA here also. So the problem is in the while loop. while. Okay. So the problem is when st is equal to en. Okay. So here we have another case. If st is equal to en, if st is equal to en, if we have yes of, here also we have two cases. If en plus 1 less than n, and else case en plus 1 is not less than n. If en plus 1, en equal to n minus 1, that means this is the last. So just answer plus equal to 1 and break. But we can have two things. If AVS of nums en plus 1 minus nums en is less than equal to 2. If this is the case, we can consider your element present at en plus 1 index in the window. So that's increment en plus plus. And in the else case, we can have one thing, answer plus equal to 1 and st equal to en plus 1 and en got incremented. Okay, these are the changes we have. So let's see with these changes it works or not. So it's giving 8. So it's giving the expected value. So let's run for the second test cases. It is working or not. So it's giving 5, but it is 6. Why it is giving 5? Okay. Okay. So if en plus 1 is less than n, we can write here one thing. C dot st en 1 2 3. Maximum in the range is not we are getting correct. n plus 1 is less than n. Okay, so we have to run this query. After this query, it will work correctly. 7 5. Why it is giving 7 5? 0 1. 0 1. Okay, 1 1. Answer plus equal to, ठीक है. 0 1 0 1 1. ठीक है. तो 0 0 0 1. ठीक है. 1 1 जब ये हुआ तो उसी समय 2 होना चाहिए आंसर का वैल्यू. उसी समय 2 हो जाना चाहिए था आंसर का वैल्यू. वन वन तो 2. 1 2. तो ठीक है. 2 2 4. 2 4. 1 2 4 हो गया. 2. ठीक है. 4 2 से 2 पे है. 2 1 2. जीरो 1 2 3. ठीक है. 2 2 4. 2 2 4. 2 6. 1 7. 4 3. 4 3 7 4 3 7 9 10 ऐसा 2 तो 4 2 6 3 होता है ना 1 2 1 2 1 2 और फिर अच्छा अच्छा 1 से 3 तक जाना था ना 1 से 3 तक गया ही नहीं 1 से 2 2 से 2 क्यों हुआ 1 से 2 के बाद 2 से 2 हो गया वेरी ठीक से काम नहीं कर रहा है so basically our query is not working correctly STEM जीरो जीरो तक में ये है 0 से 1 तक में MX ये है MN why it is giving 0 MN value is giving 0 it's MN value so don't make it MX value will be 0 and MN value will be initialize it with int max that's what it is giving that wrong answer but we have to initialize that so now it will work so we have this cout statement we have to remove and this another cout statement we have to remove now the code will work correctly so it's working correctly so it's 8 and 6 it is giving so we can submit it so it's get accepted so let's move to the fourth question so the imbalance number of a zero index integer array of length n is defined as the number of indices number of indices in SARR such that, okay, so here sorted ARR is a function that returns the sorted version of ARR. So return the imbalance number of sum of imbalance number of all its subarrays. So if we sort all of its subarray, balance number of a zero index integer array ARR of num_sen is defined as the number of indices in SARR such that, okay, so in every subarray you have to find the number of number of indices such that difference is greater than, oh, so in any subarray we have, if we are going to find the so what is basically, so we can iterate for each subarray. So for each subarray we can find the maximum value and minimum value, and in that subarray we have to also find number of element missing in the range, in that range. Okay. So how we can solve this question? So for each subarray we have to find the number of sub imbalance value. So we can run a loop for int I equal to 0, I less than, and I plus plus for int Acha, the value will be also between 0 to 1000 of this array. So let's j less than n, j plus plus int n equal to nums dot size. So we are running very out of time due to self implement. So that's it. Now we have the value present in this array will be less than equal to n. That's a big hint. Okay. Oh. Nice. Such that. Okay. So if value is greater than num say and count plus plus. क्या करें? साला this is the for loop we have.